In the last lesson, we practiced factoring, simplifying, canceling out common factors, things like that. And so in this lesson, we're going to be using basically the same techniques. We're going to do a lot more factoring. So like I said before, factoring is not your strong suit. You might want to catch up, or this chapter is going to be a little rough for you. We're going to be talking about adding and subtracting rational expressions today. So I'm going to remind you of some of the things we did with numbers. With, if you had to add a third plus a fourth, if they don't have the same denominator, you can't add them together. And so rational expressions have the exact same rules. So this opening sentence I wrote, in order to add or subtract two rational expressions, you must first find the least common multiple of the denominators. All right, so you must first find the LCM, the least common multiple, or LCM, so later I write LCM, so that's what it means. You must first find the least common multiple of the denominators. All right, so a multiple meaning it's a multiple of each denominator. And then, of course, least common. You want it to be as small as possible just so your numbers aren't outrageous and out of control. So let's start with some numbers. Get a quick little example for this. Hopefully you guys remember having to add something like 5 over 6 to something like 4 over 9. But I'm going to give you guys a technique. All right, so here's the important part. The LCM contains each factor the greatest number of times that it appears as a factor. So that's a big idea. So what we're going to do, and I know 6 and 9 you could probably just figure out pretty quickly what the least common denominator is, but I'm going to walk you through the technique that we're going to be using with the rational expressions. Okay, so with 6, we're going to factor it down into primes. So 6 is 2 times 3, and 9 is 3 times 3. Okay, so for the least common multiple, this is a little trick to how to find it. So let's read this sentence again. It contains each factor, meaning like 2 or 3 or whatever the factors are. It contains each factor the greatest number of times it appears. Okay, so 2, the most that 2 ever appears is just once. So we just need 1, 2. And then the most that 3 ever appears is twice, which means we're going to need both copies of 3. Okay, so if you look, in order to be a multiple of 6, it needs a 2 and a 3, which I have right here and right here. And then in order to be a multiple of 9, I need 2 copies of 3, which I have right here and right here. And then if I multiply out, 2 times 3 is 6, times 3 again is 18, which I'm assuming that just by looking at the 6 and 9, we probably knew the least common multiple is 18, but it's just a quick little technique. Okay? Now with the polynomials, we are going to break these down into factors. So x squared minus 3x plus 2. Hopefully we got lots of factoring done in the last lesson, so I'm hoping this is pretty quick and easy by now. So we start with x here, x here. We want to multiply to a positive 2 and add to a negative 3. First of all, if you're multiplying to something positive and adding to something negative, you know you're going to have 2 negatives. And then you've got 2 here and 1 here, or vice versa, it doesn't matter. So that's how you factor that one. The 2x squared minus 2. Always look for a GCF first, and this one has a GCF. They're both copies of 2. And then when you factor out the 2, you're left with x squared minus 1. And then you can factor that down. X squared minus 1 is the difference of squares. So it's x minus 1, x plus 1. Okay? So if you look at all the individual factors, we've got an x minus 2, an x minus 1, a 2, an x minus 1, and an x plus 1. So for the LCM, you need to make sure that you have every single piece that you need, but without having any extras. Okay, so in order to make this one work, it needs to have a 2. So my LCM is going to have a 2. We know it needs to have an x minus 2. We know it needs to have an x minus 1. And then here's where we get to the whole no extras part. This one needs an x minus 1, but it already has an x minus 1, so I don't need another copy. But I do need an x plus 1. So basically, once you think you have the LCM, here's what I want you to look for. Look at the factored version of each one. So like, here's the factored version of this. I need to make sure that both of these are present in my LCM. So I need these two terms, and here they are. So I've got those. And then look at the next one. I need to make sure that all of these are there. And I have the 2, the x minus 1, and the plus 1. The big important part is that there are no extras. We don't want to have 2 copies of x minus 1 because that would be redundant and then it would be too big. That negates the whole least idea. We want it to be as small as possible so that our calculations are easier. Okay, so this first example, we're just going to practice coming up with the LCM. All right, so this one, we're going to take all of them and break them down as far as we possibly can. So start with this one. So 12 is 3 times 4, and 4 is 2 times 2. So we're going to write 3 times 2 times 2, and then a squared, and then b. Okay, let's break this one down as well. 15 is 3 times 5, and then I have a and b and c, and then this one. 8 is 2 times 4, which is 2 times 2 times 2, and then a b cubed and a c to the 4th. I don't really need to break these down any further, otherwise you'd just be writing a times a, and you don't really need to do that. So let's come up with the LCM. It's the LCM. I have to write each factor the greatest number of times it appears. So let's see how many 2's I need. Here the 2 appears twice, here the 2 appears 3 times, so I need at least that many. That's the greatest number of times it appears. Let's see the 3. Here the 3 appears once, here the 3 appears once, which means I only need it once. And then for the 5, here the 5 appears once, so I only need it once. Okay, so then for the A, we're looking for the greatest number of times it appears. Twice, once, not at all, so I need it twice. Then for the B, we're looking for the greatest number of times it appears. Once, 3 times, once. So I need it 3 times. And then the C, we are looking for the greatest number of times it appears. Not at all, 4 times, once. So I need it 4 times. Okay, so let's multiply this whole thing together. 2 times 2 is 4, times 2 again is 8, times 3 is 24, times 5 is 120. You could, of course, just do that in your calculator if you wanted to. Okay, so that is our least common multiple. All 3 of these things will divide into this term right here that I just boxed up, and that's what makes it the least common multiple. It's a multiple of all of them, but it's as small as it can possibly be. Okay, next one. We're going to start by factoring these down. So both of them have a GCF that you can take out first. This one has a GCF of 4, so I'm going to start there. Take out a 4. When I divide that out, I'm left with an a squared minus 3a minus 4. Okay, so remember the 4 doesn't go anywhere. It's still out front. Then let's keep factoring. So I start with a and a. For these two numbers, I need to multiply to negative 4, and I need to add to negative 3. So that would be minus 4 plus 1. So that's my factored version of the first one. Now let's do the second one. So notice the GCF, all of them have an a. So I'm going to factor out an a. That GCF thing is something that people miss. Make sure that you are remembering to factor out a GCF. So then I have an a squared minus 9a plus 20 once I factor out one common copy of a. So then I keep it there. Remember, it's not going anywhere. Then I can start to factor down the rest of it. So I start with a and a. I need to multiply to positive 20 and add to negative 9. So that'll be 2 negative numbers. So my 2 negative numbers are negative 4 and negative 5. Okay, so again, I need to use each factor the greatest number of times it appears. Okay, so let's check for numbers. So I just have this 1 4, so I need that. Here's an a, so I need that. For a minus 4s, I don't need 2 of them because it only appears once over here and it only appears once over here. So just the 1 copy will be fine. And then this says I need an a plus 1, and this says I need an a minus 5. Okay, so we're trying to make sure we get the least common multiple, which means no extras. So I don't need 2 copies of a minus 4. Okay, so that's the initial idea. First very important idea of this section is to be able to find the LCM. Now we're going to use the LCM. Okay, we're going to add and subtract rational expressions. So as you probably remember from adding rational numbers, you need to have the same denominator. Okay, so it's very, very important. We have to have the same denominator in order to add these together. So I'm going to write down a little step-by-step process, and then we're going to follow it through these first handful of examples. Okay, so step one is we actually need to find that least common denominator. Okay, once we do that, steps 2 is we are going to convert each fraction to equivalent expressions. That's going to sound really weird. I'll explain it. So an equivalent expression is a fraction that's the same, like 1/2 or 2/4 or 3/6. Those are all equivalent expressions. We just need it to have the correct denominator. So we're going to convert it to equivalent expressions that has the denominator that we need, the common denominator. And then step 3 is you either add or subtract, because once they have the right denominator, they're good to go. And then kind of a little subpart, let's call this like step 3b. And that's to reduce if possible. It'll be very rarely that you're actually able to reduce, so I'm going to throw that in, not even as in its own step, but just kind of an attachment to step 3. All right, so let's follow this process. Step number 1, find the LCD. So let's start with 5a cubed b squared. That's actually already as factored as it can be because the 5 is prime. The 10ab, I can write 10 as 2 times 5. And then I have 1 copy of a and 1 copy of b. All right, so with that, let's come up with the least common denominator. So let's start with 2's. I need 1 copy of 2. That's the most that it ever appears. The greatest that the 5 ever appears is just once. Once here and once here. So I just need 1 copy of 5. The greatest number of times the a will appear is 3 times in that factor. And the greatest number of times the b will appear is twice. Okay, so I've got 10a cubed b squared. That's my LCD. All right, so that's step 1. Step 2 is we're going to convert both of these fractions to have the denominator that we want. So start with just the 4 over 5a cubed b squared. Okay, so what I'm going to do with this is I'm going to convert to the right denominator. So basically what I need to do is I need to figure out what's missing. How does this compare to this? To get from here to here, I'm missing a factor of 2. So I need to multiply by 2. But I can't just multiply the denominator by 2. I have to multiply the numerator and the denominator by 2. So that way I'm really just multiplying by a fancy 1. Okay, and I'll clean that up in just a minute. And then plus, now I do the very same thing with this next one. Okay, so we want to figure out what's missing from the LCD. What do I need to multiply in? And then we're going to do that. Okay, so I've got the 10. I need 2 more copies of A. And I need 1 more copy of B. But you can't just multiply the numerator. You've got to multiply top and bottom so that you're just multiplying by a fancy 1. All right, so now let's clean both those up. So multiply the numerators together. 4 times 2 is 8. And then multiply the denominators together and I get the LCD. And then plus, multiply 9c times a squared b, and I get a 9a squared bc over the LCD. Okay, so now they have the same denominator. Whoops, they would if I wrote that right. That's a cubed. Now they have the same denominator, so now I can go to step 3 where I add them together. So the fact that they have a common denominator tells me I can just add their numerators. So I just add 8 plus 9a squared bc all over a common denominator. And then always do a quick check to see if you can reduce anything down. I want to point out something that's very tempting but totally illegal. A lot of people will see like these common a's and try to cancel them out. Does not work like that. Not unless you can take something from the 8 as well, and you can't. So this is our most simplified answer. All right, let's look at another one. Okay, so we're going to follow the same step-by-step process. Okay, so step number 1 is we're going to find the LCD. So 16b squared. 16 is 4 copies of 2. And then a b squared. And then this is, a 5 is already factored, an a cubed, and a b. So for the LCD, we want to get everything the greatest number of times it appears. So a 2, I do need 4 copies of 2, which we know is 16. And then I need 1 copy of 5. The most that the a appears is 3 times. So I need those, and then the most that the b appears is twice. So 16 times 5 is 80. So that right there is my LCD. Step 2 is I'm going to convert both of my fractions to equivalent expressions. So for that first one, what is it missing? We have the 16. 16 times 5 gives me 80. And then I have the b squared, but I need an a cubed. Okay, and then you gotta multiply top and bottom by the same thing. Okay, next, then minus 8x over 5a cubed b. Same thing, compare it to the LCD, see what we still need. We need to multiply by 16 because 5 times 16 is 80. We have all 3 copies of A. We need 1 more copy of B. Okay, so that's what we multiply in. Those are our fancy ones. Okay, so now let's actually simplify those. 3 times 5 is 15, and then that's an a to the 5th over the LCD, 80 a cubed b squared, minus, then multiply this out. 8 times 16 is what? 100, yeah, 128. And then a b and an x, and then over my LCD. Okay, so once I'm through with step 2, they should both have the same denominator, if I did it correctly. Then I can move on to step 3, where I just either add or subtract. So I take the 15 a to the 5th, and I subtract the 128b times x. They have the same denominator, so I can put it just all over a common denominator. And just like the last one, there actually is not anything that you can reduce at all. So that is your final answer. Okay, we're going to do example 3, and then we're going to cut it there for the first half of 8-2. So these are basically the same idea. We just have polynomials instead of monomials. So these are monomials because it's just one term. These are polynomials because they have addition and subtraction. But the 3 steps are the same. All right, so step 1, we're going to find the LCD. So start with this one. We're going to factor this one down. I start with x and x. We want to multiply to -6 and add to -1. So that would be a -3 and a +2. Always double check if you're unsure, FOIL it back out. You should get the right answer. Then this one, 5x plus 10, all I can do is factor out a 5. And then I have an x plus 2. All right, so this is the factored version of my 2 denominators. So I combine up, see what I need for my LCD. So I need to make sure I have all the right factors. So I need a 5. So this one gets its 5. And then if we look, I need to make sure I have an x minus 3, so that this one's covered. And then I really only need 1 copy of x plus 2, because it only appears once in each of those factors. All right, so there's my LCD. Step 2 is to make sure they both have the right denominator. So I have x minus 1. I'm going to write this denominator in factored form, just so you can see what it has and what it's missing. Okay, so this and this are the same. We want to see what it's missing. It's got this piece, it's got this piece. It's just missing a 5. So I'm going to multiply top and bottom. I'm going to multiply by 5 over 5. And then minus, and then we start to fill in the rest of it. So now 4 over, same thing, I'm going to write my factored version, 5, and then x plus 2. So now we can look at the LCD. I have this piece, I have this piece. I'm just missing an x minus 3. So I'm going to multiply top and bottom by a fancy 1 of x minus 3. And then the denominator has everything that it needs. All right, so multiply these out, and so that we get the simplified version over the LCD. So multiply x minus 1 times 5, and I get 5x minus 5. And then here I've got all 3 pieces of my LCD. Just as kind of a shortcut in my intermediate step, I'm just going to write LCD and just leave it like that for now. Don't do that in your answer, but it's fine in the intermediate step. And then minus, here I have 4 times x minus 3. So I can distribute, and I get 4x minus 12. And then same thing, I can just write LCD for right now. Okay, so then step 3, we actually combine up. Be really, really careful here because we're subtracting. So make sure that you're subtracting the 4x and you're subtracting the -12. If you're not careful with signs, we can get an error on that last part. So I have 5x minus 4x. Combining like terms leaves me with x. And then -5 minus -12. So it ends up being plus. So -5 plus 12 leaves me with 7. And now for my final answer, I'm going to write the LCD back in. So I've got 5, and then x minus 3, and then x plus 2. So nothing that you can simplify there. We just leave it like that as our final answer. All right, and then one more of the same type. So we're going to go through the same 3-step process, starting with step number 1. So if we take a look at this, we've got 4x squared plus 21x plus 5. This one's a little weird. You might have to do a little bit of guess and checking in order to actually come up with the factors. But what we get is, instead of starting with x and x, we start with 4x and x. And then we want to know what's going to multiply to 5, but I want to make sure I get a 21x in the middle. So if I put the plus 5 right here, this gives me 20x. And then if I put the plus 1 right here, this gives me 1x. So I get my 21x in the middle. Then the second one, the 12x plus 3, I can factor out a GCF of 3. And then when I factor that out, I'm left with 4x plus 1. Okay, so those are the factored versions. Now I'm going to come up with my LCD. All right, so the LCD, make sure you take all the pieces. You need both of these pieces included. You need both of these pieces included. But the important part is that we don't want any extra. No, factors that we didn't need to include twice. So we need to make sure we have a 3. We need to have a 4x plus 1, but remember, we don't need 2 copies. Just 1 copy will be enough. And then we also need an x plus 5. So the LCD needs to be either as big as or bigger than each of the denominators. You can't make them smaller because there would be no way to divide out factors. We can always multiply in what's missing, just like we did up here. And then step 2, just like we did up above, write it down in factored form first so that we can see what's missing. So here I'm going to factor down, remember we've got 4x plus 1 and then x plus 5. So if we compare this to the LCD, notice we're missing a 3. So in order to have the right denominator, we're going to multiply into 3. We need to do the same thing to the numerator and denominator. So it's like multiplying by a fancy 1. And then plus, now write that second one in factored form. So the 12x plus 3, we're going to write it as 3, and then 4x plus 1. So same thing as we did last time. Compare this denominator to the LCD. We still need that x plus 5, so we can multiply that in. Multiply it in just like a fancy 1. 1 copy in the denominator, 1 copy in the numerator. Okay, and then we also need to actually multiply these out. So we're going to multiply the x minus 8 times 3, and we'll have 3x minus 24 over the LCD. Remember, in the intermediate steps, it's okay to kind of do a shortcut there. And then plus, now right here we're going to distribute the 6 to the x plus 5, and we have 6x plus 30 over the LCD. All right, so that's step 2. We got them to have the same denominator, which is super important because in step 3 we're going to add them together. So 3x plus 6x, we get a 9x, and then negative 24 plus 30 gives us a positive 6. Okay, so now I'm going to write my denominator back in. So I get a 3, and then 4x plus 1, and then an x plus 5. That's my LCD. So this one is the first time that I actually do reduce a little bit further, because if you look in the numerator, 9x and 6 both have a common factor of 3. So I'm going to factor out that 3, which leaves me with a 3x here, and then plus 2 over my LCD. And then notice the reason that I did this is because I have a 3 down here, and I'm going to be able to cancel out that common factor. Okay, so last step, I've got a 3 over 3, which reduces just down to 1. So it's like I can cancel out those factors. And then one last time, I'll just rewrite everything I've got here, and that'll be my final answer. Okay, so that is the first half of this section. We're going to pick up with complex fractions next time.